All right, let's talk about using mole ratios in problems. So we figured out just a second ago, we keep on figuring this out, that the balanced equation for octane and oxygen is 2 to 25 to 16 to 18. Okay, so this is the reaction. And in a previous episode, we figured out how to use that ratio, these ratios here. If I had 1.5 moles of this, and we used these mole ratios to calculate how many moles of product that they're going to have. And you just convert from moles of what you have to moles of what you want, based off of the mole ratio, which comes from your balanced equation. And you can do the same thing, not with any of the reactants or products. Say if you said, well, I want to make 2.0 moles of H2O, how many moles of each of these ingredients do I need, and how many of these will I need to react with? Okay. I'm sorry, will I be given off if I wanted to create 2.0 moles? So what you do is whatever you start out with, you put them in your equation. So here it is, 2 moles of H2O. And say you want to find the moles of octane, moles of C8H18. Well, you go down here and you look at the ratio. You go, okay. So for every 18 moles H2O, I'm going to need 2 moles of C8H18. And moles cancel, moles of C8H18, correct, looking good. And you do the math. I'm really just looking at the answer sheet when I'm doing that. Let's zoom in for fun. All right, so really, what that just did is that told me how many moles of C8H18 you created. You could also figure out, using the mole ratios, how many moles of O2 you're gonna need, and then also how many moles of carbon dioxide you'll produce. Okay, so these mole ratios are really handy, but really, I mean, it's really the heart of the problem. If you find the moles of any of these, you can find the moles of everything else. And using the balanced equation, that's the secret. Ooh, looks like I have giant hands. I'm a giant. All right, let me show you how to use this magic in the laboratory. So let's zoom back in here. All right. So how much is that? It's key to figure out the number of moles. And then in the laboratory, you're going to have to find out how much that is. And we usually measure amounts in the lab with grams, right? We use our handy scale, okay? And we find the grams of things. So we need to convert from moles to grams. So my conversion factor from moles to grams is the molar mass. Remember, I get these by adding the atomic weights of 8 carbons and 18 hydrogens. Or you look it up on Google if you're at home and lazy, and you find that the molar mass of octane is, for 1 mole of C8H18, it's 114.23 grams. So I converted, use this. Notice that the moles cancel, and you end up with grams of C8H18. So 1 mole of C8H18 weighs, if 1.5 moles weighs 171.345 grams. Now, how many grams of CO2 would you make? Oops. How many grams of CO2 do you make when you combust 1.5 moles of octane? So remember, if you have 1.5 moles of octane, they're asking you about how many moles of CO2. Well, if we knew the moles of CO2, can't we find the grams of CO2? That's right. That's right, Diego. You got it. It's just like Dora the Explorer. So we need to get to moles of CO2, and we do that by using the mole ratio. Moles of C8H18, the ratio is 8 to 1 or 9 to 2, and then moles of C8H18 cancel, and you end up with a broken pencil. Moles of CO2, moles of CO2. Once we have the moles of CO2, we got to convert to grams of CO2. So we set up the conversion factor, and it's moles of CO2, cancel, and we end up with grams of CO2. So you can figure out exactly how many grams that is. And if you're in the lab as well, dealing with gases, we can also calculate how many with the volume of a gas. And the volume of a gas at standard temperature and pressure, which is basically 0 degrees Celsius, 1 atmosphere, it's basically ice water at room you know, at sea level, at low humidity, mainly because it's just easy to get. Just dunk it in ice water and we're set, and it's pretty stable. So at STP, 1 mole of any gas is 22.4 liters. If you don't believe me, solve PV equals nRT, and you'll see that the number of moles, when you throw in all the P and the V's and the R's and the T's, you end up with a volume of 22.4 liters. So let's use that as a conversion factor. So 12 moles of CO2, 22.4 liters of CO2 for every 1 mole of CO2. The moles of CO2 cancel. We know with liters of CO2. So there it is, 268.8 liters of CO2. So let's pause for a second. 1.5 moles of C8H18 is about 171.345 grams. That is not very much liquid. Okay, so that is really not that much, and that little tiny amount creates a huge volume, liters of CO2. So you could actually create a ratio of grams of gasoline to liters of CO2, or grams of gas to grams of CO2. Already, look at this. Okay, so for every 171.345 grams of C8H18 or octane, you get at least almost around 3 times as much mass of CO2. That's because it's adding up with oxygen. So this is the problem, folks, with combustion.